Good morning to everyone. I am Dhana Lakshmi, Assistant Professor from Department of CSE, G. Pullareddy Engineering College. In previous classes, we discussed about what is the database management system and related to the database structure and related to the database environment. Today topic we are going to discuss about the ER model. In DBMS, it is also the one of the concept. And coming to the first one, ER model. So coming to this topic, what is meant by the ER model? Entity relationship model. Entity relationship model. First of all, this ER model was introduced by the Peter Chin in 1976. So this first of all, what is meant by this ER model? ER model is nothing but it is a visual representation of data that describes how the data is related to each other. Data is related to each other. Then, and one more thing, the ER model defines it is a conceptual view of a database. Conceptual view of a database. And next one, and one more thing, the ER model, it defines the conceptual view of database. Conceptual view of a database. And it is a graphical representation. And one more thing, it is a graphical representation. Everybody will ask, what is a graphical representation? Graphical representation is nothing but it is a collection of entities, relationships, and third one is the attributes. So finally, what the ER model is nothing but it is a graphical representation of the entities, relationships, and attributes. And one more thing, coming to the basic components of first one. First of all, what is meant by the entity, relationship, and attribute? Coming to the entity. Entity is nothing but it is an object or thing in the real world. Object or thing. Next one, attribute. Already we know ER model is a collection of entities, attributes, and relationships. Coming to the entity is nothing but it is an object or a thing in a real world. And coming to the attribute is nothing but properties of an entity. Properties of an entity. Next, coming to the third one, relationship. What is meant by the relationship? It describes the association. It describes the association among the entities or between the entities. Between the entities. Next, coming to the advantages of ER model. Advantages of ER model. Then what is the advantage of ER model? Then for what purpose we are using the ER model means, first advantage is it is a visual representation. It is a visual representation. And next one is it is an conceptual simplicity. Conceptual simplicity. And it is integrated with the relational data model. Integrated with the relational data model. And coming to some drawbacks are also there in ER model. Coming to the advantages is nothing but it is a visual representation. Visual representation is nothing but it is easy to understand to everyone, and it contains the conceptual simplicity. And third one is it is integrated with the relational data model. And coming to the disadvantages. Disadvantages of ER model. First one. First drawback is the limited relationship relation. Limited relationship representation. Limited relationship representation. And second one is the it doesn't support, mainly this is the one of the main drawback, it does not support DML, data manipulation language commands. ER model does not support the DML commands. Next, coming to the one example, what is the ER model, how we will draw an ER model, how we will draw an entity attribute relationship. Let's we see one diagram. First one, we consider a example student. We consider in one example student. Here we will take the two entities, student, and next entity is the course. These are the two entities. First of all, the entity is represented as a rectangle. The entity will be represented as a rectangle. And next one, student is an entity. Already I told entity is nothing but it is an object or thing in a real world. So student will contain the student is the entity. So the attributes of a student is student roll number or student name, student age, student mobile number. These four are the attributes of a student. Coming to the course attributes are, first one is the, let's we consider, first one is the course ID, next one course name. Let's student and course has a one relation because the student will enroll the course. So that's why here we have to maintain a one relationship. That relationship will be represented as a rhombus. So student will learn course or student will enroll the course. So this is all the about the ER model. How we will ER model will represented as a real-time diagram. Here we taken the one student example, student and course. These two are the entities. So in ER model, entity will be represented as a rectangle and attributes will be represented as an ellipse. Attributes will be represented as a symbol is ellipse. And next one, the relationship will be represented as a rhombus. Symbol will be represented as, relationship symbol will be represented as a rhombus or diamond. Rhombus or diamond. Next, coming to the next one, representation of entities. Representation of entities. First one, what is, already we know entity is nothing but it is an object or thing in a real world. What is meant by the representation of entities is nothing but it is a collection of entities which share common properties. It shares the common properties. It shares the common properties. Then types of representation of entities. There are two types of representation of entities. Types of entities. First one is the strong entity. And second one is the weak entity. Coming to the first one, strong entity, it should not depend on the other entity. It should not depend on other entity. Coming to the weak entity, it should depends on other entity. Because why we are telling like this, a strong entity it should not depend on other entity, weak entity it will depends on other entity means, because strong entity it doesn't need any other entity, it doesn't need any others help. Weak entity it depends on other entity, it needs some need from other person, like in real time example. Next, coming to the one example, let's we consider example. Let's we consider the relationship between student and certificate. Here student is the strong entity, and certificate is the weak entity. In this example, we will consider as a student as a strong entity and a certificate as a weak entity. Why we will consider the student as a strong entity, certificate as a weak entity means, because student must and should in college, suppose some persons or some others are studying means student is the strong entity. Certificate means suppose he will write the exam means, it is okay. Suppose he will fail any other means, if it will fail any other means, it comes to the weak entity. Next move to the entity. Then what is meant by the entity? It should be a noun in singular form. Generally, entity names will be represented as a capital letters. Entities will be represented as a capital letters. Like means, here student will be represented as a student. Here student will what we have wrote in capital letters. This is called as an entity. Okay. Next move to the entity set. What is meant by the entity set? Entity set is nothing but the group of related entities of an entity type which share all common properties or common attributes is called entity set. It shares the common properties or common attributes is called entity set. For example, this is an entity. For example, E1, E2, E3, E4. These are the entity sets. Okay. Next move to the attributes. Attributes is nothing but it is an properties of an entity. Attribute is nothing but properties of an entity. Then attribute symbol will be represented as a ellipse. For example, some will ask, for each entity how many attributes are there? There is any limit? There are no limits. Suppose we will consider one entity means, for each and every entity they will have number of attributes. More number of attributes are possible. Next, coming to the types of attributes. Coming to the first one, required attribute. Types of attributes are the first one, required attribute. required attribute, and second one is the optional attribute. Optional attribute. And the third one, simple or atomic attribute. And fourth one is the composite attribute. There are more number of attributes are there. Coming to the first one, required attribute. Required attribute is nothing but this attribute must and should have a value that is cannot be null. That is cannot be null. For example, which example we will consider as a required attribute is nothing but name. Coming to the next one, optional attribute. Optional attribute is nothing but this attribute must and should have a value or may not. It cannot be, it can be null sometimes. Sometimes it can be null. Sometimes it can be null. Value may be there or value may not be there. That is called as a optional attribute. So in name only itself is there. It is an optional attribute. Coming to the third one, simple or atomic attribute. Which example we will consider as an optional attribute is nothing but email. Email is not mandatory to each and everyone. Some persons will maintain email, some persons will not maintain the email. So email is an optional, so email is a perfect example for the optional attribute. Next, third one. Next, move to the third one. Simple or atomic attribute. This attribute cannot be broken down into smaller components. Cannot be broken down into smaller components. For example, age cannot be broken into the smaller components. Or another example, gender. Let's we break down to the gender or age. We cannot be break down age or gender. These two are the perfect examples for the simple or atomic attribute. Next, move to the fourth one. Composite attribute. These attributes that can be broken down into the two or more parts. Coming to the simple attribute, this cannot be broken down into the smaller components. Coming to the composite, this can be broken down into the two or more parts. For example, name. In name, we will split into the first name or middle name or last name. These three are the broken parts. Next, coming to the fifth one, single valued attribute. Single valued attribute. What is meant by the single valued attribute? Means this attribute that takes only one value. Example, roll number. Composite attribute will be represented as a like this, because this can be broken down into the two or more parts. Single valued attribute can be represented by the same ellipse symbol with underlined. Next, coming to the next one, multi-valued attribute. Multi-valued attribute. This type of multi-valued attribute that takes the one or more values. It takes the one or more values. For example, languages known. In name itself it is there, multi-valued. Multi-valued is nothing but languages known. For example, one student they know only one language, another student they know two languages, then another person they will know 3 or 4 languages. So that languages known will be considered as a perfect example for the multi-valued attribute. And next, seventh one, identifier. Multi-valued attribute symbol will be represented as a two ellipse symbols. Next, identifier. Identifier is nothing but it is used when this identifier is used means to identify a row unique. To identify a row unique. Same, this identifier will be represented as a same like single valued attribute symbol. Next, 8th one. Composite identifier. This is just only identifier. Next one is the composite identifier. Composite identifier is nothing but sometimes a primary key is composed of more than one attribute. Such a set of attributes is known as composite identifier. Sometimes primary key is composed of more than one attribute. Such set of attributes is known as composite identifier. Example, roll number. Why we are considering the roll number as an example for the composite identifier is nothing but roll number is an unique. And group ID, roll number or group ID. For example, CSA department belongs to the number means digit 5, then ECE 4. So same as it is like this, roll number is an unique and group ID is also unique. Next, 9th one. Stored attribute. What is meant by the stored attribute? Because stored attribute means here we are storing the attributes in a database to supply the values for a derived attribute. It is used to compute the values of a derived attribute. For what purpose we are using this attribute means to supply values for a derived attribute. Example, subject marks. Subject marks means we will consider only one subject. No, subject mark means either it is a C language or Java or C++ or Python. Any subject we will consider. That is nothing but is a stored attribute. Coming to the 10th one, derived attribute. It means whose values can be calculated from related attribute values. Whose values can be calculated related attribute values. Example, total or average or net pay, etc. Next, let's we discuss components of ER diagram. What are the components are there? Components of ER diagram. What are the components are there? We will discuss first ER model. ER model is nothing but it is a collection of, already we discussed, entities, attributes, and third one is the relationships. Coming to the first one, entity. Entity types of, how many types of entities are there? Strong entity, and second one is the weak entity. How many types of attributes are there? Either single valued attribute or multi-valued attribute or composite attribute or derived attribute. So many attributes are there. Coming to the relationships, how many types of relationships are there? One-to-one relationship. Next, one-to-many relationship. and next many to many relationship and many to one relationship. Then these relationships are also represented as some symbols. So next, one-to-one relationship will be represented as a symbol like this, or symbol means 1 to 1. Next, one to many. One to many symbol will be represented as like this, 1 to many. Star symbol will represent the many. Next, many to many. The symbol will be represented as like this. Next, many to one. Many to one. This symbol will be represented as like this. Next one. We come to the relationship. Up to now, entity, attributes are all completed. Let's move to the relationship. First of all, what is meant by the relationship? Relationship is nothing but it tells how one entity can be associated with the other entity. The association among the entities is called relationship. Association among the entities is called relationship. Next, types of relationship are there. In previous diagram already we discussed types of relationships. First one, one to one. Next one, one to many. Next one, many to one. Fourth one, many to many. For example, consider one-to-one relationship. What is meant by the one-to-one relationship? Only one entity of the first set is related to the only one entity of the second set. Example, let's consider some set. Only one entity of the first set is related to the only one entity of the second set. One-to-one relationship is nothing but only one entity of the first set is related to the only one entity of the second set. This is called as a one-to-one relationship. Next, one-to-many. So in this set we will consider as only one entity of the first set is related to the many entities of the second set. Many entities of the second set. Next, move to the third one, many to one. Let's consider two subsets, A, B, 1, 2. Here, many entities of the one set is related to the only one entity of the second set. Next, fourth one, many to many. What is meant by the many to many relationship? Let's consider two subsets, A, B, 1, 2. Here, many entities of the first set is related to the many entities of the second set. Many entities of the first set is related to the many entities of the second set. Next one, a degree of relationship. A degree of relationship. What is meant by the degree of relationship? The number of entities participated in a relationship type defines the degree of relationships. There are three types of relationships are there. That is nothing but number of entities participated in a relationship type defines the degree of relationship. There are three types of relationships are there. First one is the unary relationship, and second one is the binary relationship, and third one is the ternary relationship. Ternary relationship. Coming to the unary relationship. It is also one of the relationship between the instance of a single entity type. Single entity type. So, what is the degree of relationship of unary relationship is 1. Next, move to the binary relationship. Binary relationship is nothing but it contains the 2 entity types. Unary relationship means 1 entity type. Binary relationship is nothing but 2 entity types. 2 entity types is nothing but, so the degree of relationship binary, the degree of binary relationship is 2. Next, ternary relationship is nothing but it contains the 3 entity types. So the degree of relationship of ternary is 3. Next, a relationship set. Relationship set. A relationship set is nothing but it is a collection of similar relations is called a relationship set. It is a collection of similar relations is called relationship set. Next, relationship is set is nothing but, for example, E1, subset of E1, E2, E3. These are the relationship sets. So, for example, R1 belongs to the E1, either R2 belongs to the E2, R3 belongs to the E3. This is called the relationship set. Next topic, constraints. Constraints is nothing but it means rules and regulations. What is meant by the rules and regulations for these means for these type of relationships is nothing but, for example, to set limitations for storing the data, and it increases the accuracy and the reliability of the data stored in the database. So, number of constraints are there in database management systems. So, we discuss about the different constraints. What are the different constraints are there? First one, not null. We know already what is meant by the null and what is meant by the not null. And second one is the unique. And third one is the primary key. And fourth one is the foreign key. And fifth one is the check. And sixth one is the default. Coming to the first one, not null. Not null is nothing but whenever we want to give the data for a collection, at that time we will give the not null. For example, not null. Example, create table student roll number. The int is nothing but the data type. So roll number it is a collection of numbers, that is nothing but integers. So int is here we are giving the data type is integer. For this roll number attribute we are giving the not null. Not null means this roll number column doesn't have a null value. Not null. Name is nothing but character. So we will write the data type is varchar. So this is the not null. Next, second one, unique. What is meant by the unique? Unique is nothing but it is the same above the not null constraint, but it means without duplication. It means without duplication or repetition. Without duplication or repetition. Example, create table student student, roll number, unique. Unique is nothing but it doesn't need any duplication values. It doesn't need any duplication records, repetition records. Next, name, this is a perfect example of the unique constraint. Next one, third one, check. Check is also one of the constraint. Whenever based on condition we have to insert the value, means at that time we use the check constraint. Example, whenever we have to insert the value, means at that time we use the check constraint. Example, create table student, roll number, integer of name, varchar of 10, not null, age. Okay. For this age attribute, we will use the check constraint. Why means, for example, age is greater than or equal to 18 means we will not consider. Suppose age is less than or equal to 18 means we will not consider. For this type of problems only we use the check constraint. And next one, default. Default is nothing but to set the default values for a collection when no value is specified. Here we are setting the default values for a collection when no values is specified. Example, create table student, roll number, integer 4, name, varchar of 20, default, new student. Suppose whatever we considered one of the table for student, real-time example, in that table, suppose in any column value will not considered means, value will not displayed means, at that time we will use the default constraint because automatically it will fulfills the new student. Next, fifth one, primary key. What is mean by the primary key? Primary key is nothing but it is a field or column which can uniquely identify each row in a table, and it maintains the unique collection, unique collection and not null. Unique collection and not null. Then what is the advantage of using the primary key is nothing but here main advantage is data is properly maintained. Data is properly maintained. Data is properly maintained. Let's take one example of the primary key. Let's we consider one example, student, roll number, student table name is the student. Then what are the attributes will come for the student? First one, roll number, second one, name, and third one, marks. In these three attributes, for which attribute we will consider as a primary key is nothing but primary key, it should be unique. So here in this table, roll number we will be considered as a primary key. So primary key must contain the unique values and it cannot contain the null value. So main what we know means unique plus not null. Unique plus not null equal to primary key. For single sentence, what we have to told means unique plus not null equal to primary key. Next, foreign key. Foreign key. Foreign key is nothing but it is also a field or collection, points to the primary key of another table. It points to the primary key of another table. It points to the primary key of another table. And what is the advantage of using the foreign key means it maintains the relationship between the two tables. Next one, generalization. Already we discussed about the relationship topic. How many types of relationships are there? One-to-one relationship, one-to-many, many-to-one, and many-to-many relationships are there. But let's come to the point. Generalization and specialization also special type of relationships are there. Let's come to the generalization. What is meant by the generalization? Generalization is nothing but the process of creating a more general entity type from a set of more specialized entity types is called as a generalization. Mainly general entity type from a set of specialized entity. Specialized entity type is called as a generalization relationship. Well, mainly what is meant by the generalization is nothing but the process of extracting the common properties from a set of entities and it creates a generalized entity from it. And the generalization relationship, it follows the bottom-up approach. Bottom-up approach symbol will be represented as a like this. Generalization relationship will be it follows the bottom-up approach and the symbol will be represented as a like this. Next, and it can be in which two or more entities that can be generalized to a higher level entity if they have some common attributes, and it forms a supertype from a set of subtypes, and it forms a supertype from a set of subtypes. Because it follows the bottom-up approach means it forms a supertype from a set of subtypes. This is the supertype. We consider one example. Car is an entity. Then attributes of a car is name, number, cost, number of seats. We consider another example, because why here we are taking the two examples, car and a truck, means because here we have to maintain the generalization relationship and we have to show the generalization relationship. Here truck is an entity. What are the attributes of the truck? Truck name, truck number, truck cost. Attributes are the same because car is an vehicle and truck is also an vehicle. Same specifications are there. And truck is the additional permit. Next attribute, capacity. For these two entities, how we will generate a generalization relationship, we see in another page. Next one. For example, here car and truck is an vehicles. So vehicle is one of the entity. Next, truck and car. Next, for truck, different types of entities are there: capacity, permit. In previous example, here truck how many what are the attributes are there means truck name, truck number, and a truck cost. Additionally different attributes which one are not there is nothing but capacity, permit. Let's move to the first vehicle. Vehicle means what are the attributes are there. In previous example, how many common attributes are there, how many different attributes are there. First of all, we will split. So here how many common attributes are there? Name, number, and cost. Here also name, number, and cost. Let's move to the next page. Here vehicle, name, number, and cost. Next, for these truck, what are the different attributes are there? Capacity and permit. Capacity and permit. For these car, what are the different entities attributes are there? Number of seats. Number of seats. Next, here this is called as a relationship means, so we have to draw a generalization relationship symbol. Easy. Here X we see truck is a vehicle. Vehicle must and should have the vehicle name, vehicle number, and vehicle cost. Here car is also an vehicle, and it follows the bottom up approach. Finally, generalization relationship, it will form a super type from a set of subtypes. These capacity, these truck and car is the subtypes, and it forms the super type. Here vehicle is the super type. Here truck and car is the subtypes. Next, one, specialization relationship. What is meant by the specialization relationship? An entity is divided into the sub-entities. Entity is divided into the sub-entities, that is based on their characteristics. And one more thing, generalization, it already follows the bottom-up approach, and specialization, it will follows the top-down approach. So these top-down approach symbol will be represented as a top-down. An entity is specialized into the 2 or more lower level entities, where higher level entity is specialized into the 2 or more lower level entities, and it forms the subtypes. From a super type, because it follows the top-down approach. So it forms the subtypes from a super type. Example same like a generalization relationship, reverse of generalization relationship. Generalization follows the bottom-up approach, and specialization will follows the top-down approach. That's it. Next, coming to the relational model. A relational model. First of all, what is mean by the relational model? Relational model. Here, a relational model is nothing but, in this model, the data will be stored in table format. Already we know about what is the database management system and what is the relational database management. First of all, we will consider one simple clear-cut example. First of all, what in DBMS, everybody will know. Everybody will have some doubt. In database management system and RDBMS, database management system and relational database management system, it will be same or not? It will be same, but a data storing managing capacity is some different. So in database management system, the data will be stored in file format. Coming to the relational database management system, here the data will be stored in table format. This is the basic difference between the database management system and RDBMS. In DBMS, the data will be stored in file format. In RDBMS, the data will be stored in tables format. This is the simple basic difference between the DBMS and RDBMS. Next, move to the relational model. First one is the introduction. Introduction to the relational model. Introduction to the relational model. This ER model will be converted into the relational model. In previous slides, we learned about the ER model, entity relationship model. In this relational model, ER model will be here. What going to happen in relational model is nothing but these ER model will be converted into the relational model. Relational model. So a relational model will be can be implemented by using the RDBMS. So these relational model can be implemented by using the RDBMS. Then RDBMS is used to implement the relational databases in system. For these relational database management system, examples are the SQL or MySQL or SQL Server, etc. Finally, first of all, this relational model was developed by the EF code in 1970s. Mainly for what purpose we are using the relational data model? Relational model is nothing but here we are representing the data in the form of relations. Here we are representing the data in the form of the relations. Relations is nothing but tables. Tables contains the rows and columns. Rows and columns. The next, basic term analysis. Basic terminologies. First one, in ER model, how many types of are there? Entities, attributes, and relationships. Coming to the relational model, what are the basic terminologies are there for a relational model means? First one is the attribute. Attribute is nothing but it is a collection of a table. Second one, tuple. Tuple is nothing but row. First of all, table contains the rows and columns. In a relational model, what we will call as a row is nothing but tuple. Next, third one, relation. Already we know relation is nothing but a table. Table contains the rows and columns. Rows will be called as in relational model is nothing but tuple. And fourth one, relation schema. Relation schema. Relation schema is nothing but it represents the relation name with its attributes. It represents the relationship name with its attribute. Next one, a relation instance. Relation instance. The number of tuples of a relation is at a given time. The number of tuples of a relation at a given time. Next, sixth terminology is nothing but degree. Degree is nothing but the number of attributes of a relation. The number of attributes of a relation is nothing but, for example, we will consider an student. Student is an entity. This student entity, student name is the one of the attribute. Student age is the one of the attribute. Student roll number is the one of the attribute. For this type of student entity, what is the degree of this student is? The degree of relationship of the student is 3. 1, 2, 3. Next, fourth one. Degree is nothing but the number of attributes. So for this student entity, how many attributes are there? 3 attributes. Suppose we will included one more attribute, means student mobile number. So now how many attributes are there for this student entity? 4. The degree of attributes is the 4. Next, seventh one is the cardinality. Cardinality is nothing but number of tuples or rows of a relation. The number of tuples or rows of a relation. Eighth one, null values. Null values is nothing but unknown values. Null values means there in their whenever null value is there means they didn't specify any value, they didn't given any value at that time. Unknown values or unavailable values. Because null value means it is equal to 0, means it is not equal to 0, but it specifies the some white space. Next one, domain. Domain is nothing but each and every attribute has a domain, that is a type and range of values allowed to the attribute. Example, data types. Next, key. Key is nothing but it is also one of the attribute which is used for unique identification. Of each row of the table. Next comes to the next topic, SQL. What is mean by the SQL? SQL is nothing but it is a structured query language and it is a standard language for RDBMS. SQL is nothing but it refers to the structural query language and it is a standard language standard language for RDBMS. For what purpose we are using the SQL queries means to create the database tables, to create the database and to update database and to delete the database and to alter the database. For this purpose we are using the SQL for a relational database management system, to create the database tables and to insert the data or records and to perform the manipulations on the records. Here we are retrieving the data or to delete the records. Finally, mainly it is used for implementing the relational database management system software. Already we know in SQL we will discuss about the SQL queries. First of all, what is meant by the query? Query is nothing but it means a statement. It means whatever we are doing operations in tables, that is called as a query. How we will write as a query means select salary from employee, semicolon. This is an SQL query. SQL query. Query is nothing but it means a statement. So this is all about the entity relationship model and the relational data model and SQL.